This is the Conat 4 compass, which is made by Breithaupt in Germany. It's the official compass of the German army. In this video, I'll show you how to use one of these compasses to navigate with. But before that, what I'll do is I'll go through all the various parts of the compass, just so you know what I'm talking about when we start navigating. To navigate with this, all you really need to be able to do is you need to be able to set your compass to a bearing. You need to be able to follow a bearing. Some people call a bearing an azimuth. You need to be able to find out where you are on a map, and also how to deal with magnetic declination. Now, there are, as with all compasses, many other things that you can do, but providing that you can do those four things: set a bearing, follow a bearing, find out where you are, and deal with declination, then you're good to go with this compass. You should be able to use it to navigate around the hills. Oh, on this point, by the way, of covering everything you need to know, it's very easy to overcomplicate things. So the trick is, as always, to keep things very simple. So hopefully today I'll keep things as simple as I possibly can. Oh, a quick disclaimer first before we start. Everything that I use in my videos is my personal property, which I've paid for with my own money. I'm not sponsored by, nor do I receive any benefit from any compass manufacturer or anyone else, in fact. Yes. So let's get on with it. Why is it called a Conat 4? It's easy, that. It's an amalgamation of the first part of the word compass, C-O, and the first part of the word NATO, N-A-T. So C-O-N-A-T, Conat. There you go. The reason for this is that in the 1950s, the newly formed Bundeswehr, German army, was being integrated into NATO, and their equipment, including their compasses, had to be compatible with NATO standards, and that's why it's called the Conat. It's the Conat 4, quite simply because there were 3 models before this compass. So let's get on with it. I'll go through all the parts of this compass that I've found, and if I miss any, let me know in the comments box, especially if you're in the German army or you were in the German army, because you obviously know much more about this compass than I do. There's 3 main sections to this compass. There is the body, which is this section here. There's the mirror, which is this bit, and there's the dial. Let me get a pointer. I know, that's all I could. I've got a piece of grass. I know. I should have a laser printer or some sort of projection system, shouldn't I? You could project it onto that rock back there so you can see what I'm talking about. But all I've got is a piece of grass. When I become a real YouTuber, I'll get some more equipment. Until then, we'll just muddle by. So anyway, stop it. Right, so the body is hinged, so when it opens, the mirror lifts to around 60 degrees. And along the edge of the body here, you can see there's a metric ruler. So you can measure on a 1 to 25,000 map, you could measure up to, what's that, about just over 2.5 kilometers using this. In the top section, there is the forward sighting loop, which is this, which has got a luminous pointer on it, which makes it useful in reduced visibility. Below the forward sighting loop, there's the small closure clip, and that goes into the depression at the lower bit here. So when you close the compass, it stays closed. Inside the top section, there is the manufacturer's part number. I won't read it out, it's quite long. 00327, and then lots more zeros. This is the manufacturer's code, which identifies this particular model of compass. The military may have a different set of numbers, who knows. There's also the identification number, which in my case starts 498, and then I won't read the rest out, and I'll also blank it off on the video. There are, I'm not sure how to put this politely, on some well-known websites, is that the best way of putting it? There are an awful lot of fake Conat 4 compasses, or compasses that look very similar to this. If you want to know if yours is a genuine one, as long as you've got this number that's inside the top section there, you can email that direct to Conat, and they will tell you if it's a fake or not. I bought this direct from Conat. Direct from Conat. I brought this direct from Breithaupt in Germany through their English agent. But as I said, you can check if they are. Also in the top section is this round depression, and this holds the mirror either when it's flat or when it's fully open. You can actually embed the mirror into it. So that's that. In the lower section there is the direction arrow, which is this section here, and that's about it really. That's all I can tell you about the body itself. Oh, there's the lower sighting notch here. I'll go through how to use that later on. The next section is the mirror, which is all this bit here. Okay, and there's a sighting hole in the base, as you can see, and there's also a sighting, I don't know what we're going to call it, a sighting slit in the center of the mirror. And there's also a warning in German. If you're from Germany, please forgive my German accent. I haven't got one. Nicht nach unten drücken. That basically translates as do not press down, and that is very, very important. If, when the compass is open like this, if you get the mirror and you press it down, you'll break it and you'll have to buy a new compass. So don't press the mirror down. Really important. Now let's have a look at the dial itself. I'll hold this up. Running around the top edge we have a set of serrations. This just makes it easy to rotate the dial, especially if you're wearing gloves. Around the inside of the dial it's marked in two sets of numbers. In the black numbers are NATO mils and the red numbers are degrees. Underneath those numbers the whole area is luminous, so it makes it easier to use in the dark. And you've also got the cardinal points, north, south, east and west. The small black line that you can see just at the top of the dial, just below the center of the hinge, that's the index mark. The index mark it's really important that you know where that is, because once we start navigating with that compass, we'll be using the index mark quite a lot, so that's an important thing. In the center of the dial, there is the east-west line, and there are also some other lines which are the orienting lines. And in the center of those orienting lines is the orienting arrow. Once again, the orienting arrow is very important when you're actually using the compass to navigate. I'll show you how to do that later. There's a magnetic needle which it isn't colored. It hasn't got red at one end and white at the other end. It's just black, and it's also pointed at both ends. The north end of the compass is slightly more pointed than the south end. I won't say fair enough. If we zoom in on the center of the dial, you can see that this is a global needle. So there's a small circular magnet which rotates, and the needle is attached to the top of the magnet. And as the capsule is quite deep, this means that the needle will still rotate when the compass is held, at a good angle. So this makes it a global needle, and so it should work in most parts of the world. Also inside the dial, mine doesn't seem to rotate very much, is the inclinometer. An inclinometer is used to measure a slope. All you do to use that, I'll go through that quickly, set your compass at west, so the W is directly above the index mark. So it's here, the W is directly underneath the west. Open the compass up, point it up a slope, and then where the black line at the end of the inclinometer points to on the degrees scale, that is the angle of the slope. Okay, so it's there are lots of ways to get the angle of a slope. You don't have to use the inclinometer. I made a video about how to do that. I'll put the link in the description box. Okay, the other part of this compass is the thumb loop, and obviously the lanyard. These lanyards actually are really good. The only lanyards that I've seen that are actually long enough when you buy them are from Kamenga in America, and these from Germany. So come on, Silver, Sunto, etc., Brunton, sort out your lanyards. We want more. We want bigger lanyards. Do you think they will? No. Anyway, the thumb loop. Now, this, if you're used to using other types of compasses like like Kamengas and what have you, you have to note the thumb loop on this is used differently than with other military compasses, such as the British Francis Barker M73 or the American Kamenga 3H. But I'll go through that later on. But the thumb loop is actually used differently on this compass. So that's all the parts of the compass that I can find. So now, finally, let's look at how we use this compass to actually navigate with. And the first thing we need to do is, whenever you're navigating, the main thing you need to do is you need to know, which way do I go? Do I go that way or something? So to do that, what we're going to do is we're going to set this compass to a bearing. And if you're not sure what a bearing is, you can think about it as a direction. Imagine you're standing in the center of a circle, and the circle has been divided into 360 equal segments. And each segment is numbered from 0 to 359. 0 marks north. So if you want to walk north, you walk towards the 0. I know I know that's not exactly correct, but it'll do for today. So if you want to go north, you walk towards the 0. So obviously, if you wanted to walk south, you'd walk towards the 180 number. Or if you wanted to go west, you'd go towards the 270 number, etc., etc. These numbers are called bearings. And as I said, some people will call them an azimuth. There is a difference between a bearing and an azimuth. But I made a video explaining all about that. So I'll put the link in the description box. But I shan't be going through that today. So it doesn't matter really whether you call it an azimuth or a bearing. The main thing with navigation is always, as long as everybody that needs to understands what you're saying or what you mean, that's fine. Don't get hung up on technical words. So there are three main ways to get a bearing. So you might know the bearing. I'm going to walk on a bearing of 1, 2, 3. Or somebody may tell you. So you've got a known bearing. You can take a bearing from a map, and you can also take a sighted bearing to a ground feature. So as an example, I could take a bearing to that rock there, and then if for some reason the fog came down really thick, I'd set my compass to that bearing and I'd still be able to walk to that rock. So those are the usual methods of getting a bearing, when you're walking around the hills. There are other ways, because somebody will comment, for example, you can get reciprocal angles, you can get course conversions, but they're not very often used by civilians, unless you're on one of my advanced navigation courses. So firstly, let's use the simplest method there is of setting your compass to a bearing. That would be a bearing that you already know or somebody's told you. Let's say that you want to walk on a bearing of 345. Don't forget that the degrees are marked in red inside the dial, and NATO mils are marked in black, the black numbers. All you're going to do is rotate the dial until 345 is directly over the index mark. Don't forget, the index mark is the small black line just below the center of the hinge. So my compass is now set on 345, as you can see, and that's it. Your compass is now set. How easy? Honestly, some people think navigation is difficult. It's honestly not. It's really simple. If it wasn't simple, I wouldn't understand it. So let's go through now the other two methods. What to do with your compass, how to follow that bearing. We'll go through that in the next section. But for now, let's look at the other two methods of setting your compass to a bearing. Well, the next one we'll take our compass and we'll take our bearing from a map. So I haven't actually got a map today, so I didn't bring one. Not a very good navigation instructor, I know. But anyway, I'll do it from memory. You open the compass until it's lying, so it's fully open like this. And then you place the edge of the compass on your location and also your destination. Let's say you want to walk from here to a wall junction. the edge of the compass should be running through your location and also through the wall junction. To make this as accurate as you can, make sure, or try and make sure, that you can actually see either the horizontal lines on the map, most of the time they're blue, the horizontal lines or the vertical lines. Look through the center of the dial. You may have to move your compass around slightly until you can actually see those lines, but still ensure that the edge of the compass is running through your location and through your destination. All you're going to do next is rotate the dial, the whole dial, until the orienting lines are pointing straight up the map, or hopefully parallel to the vertical lines on the map. On this particular compass, there's an east-west line, so you can also do this using the horizontal lines on your map. Okay, now the bearing is the number that is, once again, directly over the index mark. I told you the index mark is very important on all compasses. I would use the red numbers, the degrees, but if you're in the military, you may want to use NATO mils, that's up to you. So, and then all you do, read your bearing underneath the index mark. The next thing we'll do is we'll take a bearing from a ground feature, okay? And this is where we see the difference between the Conat 4 and other military compasses. As an example, this is an American Kamenga 3H, and this is the official compass of the US Army. And this is the Francis Barker M73, and this is the official compass of the British Army. Although I know that both militaries, all militaries all over the world, also use normal sort of plastic compasses as well, just because they're a lot easier to use. But these are the official compasses. The main difference between the Conat 4 and these other military compasses is that, as an example, on the Kamenga, what you've got is you've got a lens. This is a lensatic compass because it's got a lens. You look through the lens and then you can focus on the very tiny numbers that are inside the dial and you can read your bearing. The M73, the British one, it doesn't have a lens, it has a prism, which is why it's a prismatic compass. When you look through a prism, prisms bend light, as you probably remember from school. And you sight your compass on something in the distance, a target, and when you're doing that, the prism will project the bearing into the lower section of your eye. It's like the head-up display of a fighter aircraft or a very expensive car. So prismatic and lensatic. Now, put these down. This Conat 4 is also a sighting compass, but it doesn't have a lens or a prism, so it's used differently. And so what we're going to do is this. I'll come forward so you can see. We're going to bend the thumb loop down and place our thumb through the thumb loop and support the compass on our thumb and our forefinger. With the other two types of compasses, you would normally do this, but obviously because it doesn't have a lens, your eye is too close to the numbers, you can't focus on them. So what you do is point the compass at something, support it with your other hand so you get a good solid base like this, and then looking through the rear notch, through the sighting hole to the forward sighting notch, place the forward sighting notch on the target, and then look in the mirror and rotate the dial. You rotate the dial until the orienting arrow, the tip of the orienting arrow, is directly under the north end of the magnetic needle. Okay, I'll say that again. Might sound a bit complicated, but it's not. It's really not. Once you get used to doing it. Point your compass at something that you want to take the bearing of. Look through the rear sighting notch and the sighting hole and place the front sighting notch onto the target. Okay, look in the mirror and rotate the dial until the pointed end of the orienting arrow, don't forget that's the black arrow that's printed inside the dial, is directly underneath the north end of the magnetic needle, and you can see that in the mirror. If the target is below you or above you by too much, that if you do this or this, the magnetic needle won't rotate correctly. So that's what the slit is in the mirror for. You could, instead of looking through the sighting hole, you look through the slit in the mirror, and then you can actually lower it down. You can, you can do this slightly, but if you do it too much, the needle won't rotate. And don't forget, look there, look in the mirror, rotate the dial until the pointed end of the orienting arrow is directly underneath the north end of the magnetic needle. And then you read your bearing from underneath the index mark. I told you index marks are very important. So once you've done all this, if you look, the bearing is directly above the index mark, which again is the small black mark just below the center of the hinge. So that's 3 methods of getting a compass bearing. It was either a known bearing, somebody told you, or you knew what it was. It was a grid bearing, in other words, you took it from the map grid, or it's a magnetic bearing, which is a sighted bearing to a ground feature. It's magnetic because you're using the magnetic needle to take the bearing. Your compass will need adjusting in most parts of the world for declination, but we'll go through that in the next section. But for now, let's say that you have a bearing of 123 degrees. All you're going to do, open the compass and rotate the dial until 123, like this. So 123 is directly under the index mark. I told you the index mark is very important on these compasses. Now the next section is, I would say, if you keep things simple, they're much less likely to go wrong. And some of the times when things go wrong, it doesn't matter, just sort it out later on. But there are situations, you know what I'm talking about, where getting something wrong, especially with navigation, can have serious consequences. So the trick is, keep things simple. Don't overcomplicate anything. What we're going to do is this. Let's say I've got my bearing of 123, which happens to be in that direction, but I'll face you just so you know what I'm talking about. Hold the compass in front of yourself. So it's like this, just above sort of chest height. So this. And then rotate your whole body until the magnetic needle is directly over the tip of the orienting arrow. So here we go. So it's like this. If you hold it with 2 hands, the reason for doing this, by the way, it's not a hard and fast rule. We've all seen these videos and read these websites. You must do this, otherwise this will happen. Half of the time that's just rubbish. You can do whatever you want, but this is how I would suggest you do it, because it's simple and therefore less likely to go wrong. But if you don't want to do this, it's up to you. This is how I do it. Hold your compass in front of you at chest height. Rotate your whole body until the tip of the magnetic needle is directly over the orienting arrow. Okay? This way, your whole body is facing the way that you're going to start walking. Your ears, your shoulders, your hips, your knees, your big toes, everything is pointing in that direction. And when you set off, that's the way you go. But if you do this, I'm going to go over there. That's my suggestion. If you want to do that, that's totally up to you. The next thing we're going to do is, if you can see your destination, what's over there, and you can see all the way to it. In other words, there's no dead ground. As an example, if I'm going to walk to the other side of the valley over there, there's dead ground. So it's not going to work. So if I'm just going to walk, and I can see all the way to my target, there it is. Yeah, I've identified my target. Off you go. Put the compass in your pocket and walk to it. Dead simple. Most of the time when you're out in the hills, that's not the case. So let's say that, I don't know, I'm here and I want to walk over here to that rock over there. Yeah. Now, I know it's bear with me, it's a video. So what I'm going to do is I'm going to turn around and I'm going to do this, and I know that I want to walk to that rock. The problem I've got here is, imagine there's some dead ground in between it. There's also this big boulder. I don't want to climb over that, get my nice trousers all dirty. So what I need to do is this. look along your bearing and see something that you can walk to. And in this case, I can see that large tuft of grass just there. So now I've got it here, I'm going towards that. Put your compass in your pocket. I've seen people walking across the hills like this. Yeah, don't do it. I'm going to walk to that tuft of grass. Now the beauty of doing it like this is I can put my compass in my pocket, and now I can leave my bearing. I don't have to go in a straight line. Honestly, this is the way to do it. There's my tuft of grass. I can walk to it. I can go round this large rock. I can, if I wanted to, I could go up this small hill and here. And now I'm at my tuft of grass here. What I then do, I'll come back over to where so you can see me. I'm not sure how good this camera is. So what I'm doing is I'm going to go to intermediate points. In other words, look for something along the bearing. There it is. If I want to be really exact, what I can do is I can sight like this. And sorry, that's with a lensatic or a prismatic. What I can do is I can use the compass like this, and I can sight something exactly. But normally when you're walking, it's just enough to hold it here. Yep, I'm going to go to that. And then when you get to that intermediate point, do it again. And you keep doing that. You're leapfrogging along until you're close enough that you can actually see your target. Okay, the main thing is with that, put your compass in your pocket. Okay. Now, an important point on this, following bearings. When you're walking to an intermediate point, it must be something you can touch. There are clever people will come up with better ways to put that, but in my simplistic terms, I will say walk to something that you can physically touch with your hand. If you can't touch it, then don't walk towards it. As an example, I want to walk to my rock there. In a straight line, I can see the horizon up there. Yeah, so I don't start from here walking to a point on the horizon. That's just mad. Because what will happen is when you're following a bearing, you very rarely walk in a straight line. In fact, in an area like this, it's almost impossible because it's full of things like this. Limestone. There's limestone pavement all over the place in this area. So if you take a sighted bearing to something on the horizon, what will happen is I'm walking along and here I am, and I've come off my bearing, and I think, hang on a minute, I better check, and I'm still walking to the point on the horizon. And what will happen is you will invariably end up walking in an arc. You're still always pointing to this thing on the horizon, but you've left your bearing slightly and you're still walking. Now, if you walk in an arc, say I end up over there, I'm heading towards that big rock. My arc will go around my destination. Okay? So don't point at something on the horizon and walk towards it. You must always use an intermediate step that you can physically touch. Okay? So don't do it, especially at night. As people who are on my advanced navigation courses, we go walking around this area in the pitch black, and I think it's really good fun. But some people, everybody's wonderful on my courses. They're all amazing people. Anyway, so the main point of this is use your compass to follow your bearing, but keep it simple. Get it in front of your body like this. Find something you can see and touch. Walk to that. Get your compass out again. Do it again. Do it again. Obviously, your main navigation tool isn't your compass. I know on a video like this, I'm supposed to say, oh, compasses are wonderful and etc., etc. Your main navigation tool is your map. Yeah, but I'm not here today to talk about map reading. I'm here to talk about how to use the Conat 4. Up to now in this video, we've been talking about how to set your compass to a bearing and how to get a bearing and how to follow a bearing. But this all supposes that you know where you are. If you're going to walk from somewhere to somewhere else, you need to know where you're starting from. There are lots and lots and lots of ways to find out where you are on a map. But today, as we're talking about one of these, the Conat 4 compass, we'll look at one method you can use that's very simple using one of these compasses. The first thing to do is look around you and find something that you think you can identify on a map. As an example, let's say there's a wall junction over there, or there's a trig point or a pointy hill or something. Doesn't matter what it is. Have a look at that and then identify that on the map. Then, if you're standing on a linear feature, it makes it a lot easier. It really does. What we're going to do is we're going to use our compass to take a sighted bearing to that feature. I keep doing this, don't I? Lensatic, prismatic. So let's have a look. So here we are, we take our bearing and we've got a bearing of 1, 2, 3. I wonder how many things in my videos are actually on a bearing of 1, 2, 3. The vast majority. So what we're going to do is we're going to hold it up, we're going to rotate the dial, and we're going to find out what the bearing is to that feature. Then find that feature on the map and place the edge of the compass on that feature on the map. And then, without touching the dial, so it's still set on the bearing of the ground feature, keeping the edge of the compass touching whatever it is you're looking at on the map, simply rotate the entire compass without touching the dial, keeping it touching the feature on the map until the orienting lines are pointing straight up the map. Or on this Conat 4 you can use the east-west lines. They're going perfectly horizontally across the map, but it's easier to use the orienting lines. Rotate the whole compass until the orienting lines are pointing directly up the map. They're running parallel to the vertical blue lines on most maps. Assuming that the edge of your compass is still touching that feature, where the edge of the compass runs through the linear feature on the map, that is your location. A linear feature it's anything that forms a line on a map. That could be a stream, it could be a wall or a track or anything. If it forms a line, it's a linear feature. But what happens if you're not standing on a linear feature? In that case, you need to take a bearing from two different things that you can see them on the ground and you can identify them on a map. Then what you do, take your bearing to the first feature. What I tend to use is some people draw lines on their map. I tend to use bits of grass. So I simply do exactly the same as we discussed sort of a few seconds ago. Put the edge of your compass on the feature and rotate it until the orienting lines are pointing straight up the map. And then put your piece of grass, or if you want to, draw a line on the map. So you are somewhere along that bearing on the map. Then take another bearing to something else. Don't take two bearings that are two features that are quite close together. Get them quite far apart, so the lines on the map make a good angle. Then draw that second line on your map, or get another piece of grass, and where the 2 points touch, where they cross, that is your location. I'll drop all this onto your screen when I get home, because it's a lot more easier when you can actually see it in action rather than me trying to explain it. But that would be doing a resection. Triangulation. Sailors do triangulations, walkers do resections. A walker, as long as you're standing still, the idea is we just need two lines on the map, and where they cross, that's where we are. Sailors normally need 3 lines. It's called triangulation. The idea being is, as they're doing all this and drawing their lines on the map, because I know nothing all about anything to do with maritime navigation, by the way, but I know that boats move with the tide or the wind or something. And so they will draw 3 lines on the map, and this will form a small triangle, because on the assumption that they've moved whilst they were doing their bearings. and you are somewhere within that triangle. That's why it's called triangulation. Anyway, so that's how to find out where you are on a map. As I said, there are lots of different ways of finding out. You can always find out your location on a map. It's not difficult, but that's just a method that you can use with a Conat 4. And because this is what we're discussing today, I thought I'd go through this. Right, now let's get on to declination. First of all, magnetic declination. What exactly is it? Well, here's the thing. You can actually spend hours and hours explaining declination in great detail. I've got lots of videos explaining it and how to cope with it and all the rest. But this video is just about the Breithaupt Conat 4 compass, not the physics of the Earth's magnetic field. So I'll keep it as simple as possible. Just enough so that you can understand why we need to adjust the compass before we set off walking. Otherwise we'll be walking in the wrong direction. Let's say that you've got a map and you've got a compass. The vertical lines on your map point to the top of the world. That's the axis where the Earth spins around. If you imagine pushing a long straight needle all the way through the planet to the South Pole, the vertical lines on your map, they converge where this imaginary needle passes through the Earth's surface, and that's at the North Pole. Your compass needle, however, it points somewhere different. If you think about the Earth as a big magnet, like any magnet, it has a magnetic field. And your compass needle aligns itself with that field. And it points towards a place at the moment at the top of the world, where all the magnetic field lines come together and they go back into the ground. The difference between the direction that your map points to, the vertical lines, and your compass is called declination. And yes, I know, before anybody comments about grid magnetic angles and true north and grid north and all the finer details, I know. But today we're keeping things really simple. So we're going to say that the compass points to the magnetic North Pole, and the lines on your map point to the North Pole, and the difference is called declination. That's what we're going to say today. So this means that your map is pointing one way and your compass needle is pointing in another way. And to navigate accurately, using the map and the compass, we need to make an adjustment. Now, obviously, you can't change a printed map. Once it's printed, that's it. So the only thing that we can do, if we have to make an adjustment, we're going to have to adjust the compass. Okay? And there is an easy way to find out the amount of declination in your area. And that's just go online, Google it, just put magnetic declination and then your local area, and it'll come up, with the answer. If you're in an area like this where I have no mobile phone signal, there's no internet up here, then all you do is find something on a map, a wall junction or a trig point, something is in the right place on the map. From your location, take a sighted bearing and then take a map bearing. So remember we did that to start with. We took a map, take a bearing off the map, and we take a sighted bearing using the compass. The difference between those two bearings is the current declination in this area. Let's say that you've gone online and you found out that your local declination in your area is 10 degrees west. In this case, if you take a bearing from a map, so it's a grid bearing because you're using the map grid, and if you want to use that bearing on your compass, to follow to a destination, then you're going to follow a magnetic bearing because you're using the compass's magnetic needle. Now, this you can see why some people like to permanently adjust their compass. Some compasses can be more expensive compasses. They can be semi-permanently adjusted for declination. So you don't need to do any of this east to west, mag to grid, etc. You just don't need to do it. Now, the Conat 4 is one of these compasses that can be adjusted, and that gets rid of all of the maths, so you don't have to do anything. So whether you're going, from a compass bearing or from a map bearing, once your compass is adjusted, That's it, that's all you have to do. As an example, Silver and Sunto, they're more expensive compasses. They have little screws on them, and you can turn those, and that alters the direction that the orienting arrow is pointing. And you know, that's how it works. Some other companies like Brunton, they have a hands-free method. You squeeze the center of the dial and you can rotate the bezel, and that will permanently change your declination. It adjusts the direction that the orienting arrow is pointing. This Conat 4 has probably got the easiest and simplest permanent declination adjustment that I've seen on any compass. So if you've got one of these, you're in luck. I'll zoom in on this when I get home, and I'll put it on the screen. To adjust this compass, let's say we have a declination of 10 degrees west. All you do is hold the compass steady, use 2 fingers or more if you want, but lift the entire dial. You'll see that it's on a small spring. Just lift it and then rotate it 10 degrees. How simple is that? My compass is now adjusted for magnetic declination. If I had an east declination, then I would simply lift it up and I would adjust it to the east. I mean, it really is. The dial itself on these things is as I said, it's on a small spring or something. And it's probably the simplest one I've ever come across of all, and I deal with a lot of compasses. But this is brilliant. Whoever invented this idea they want a pat on the back. Lift the compass, rotate the dial until the magnetic declination is adjusted. I always find that, by the way, to do this, it's easier if you have the north pointing, you know, directly up the compass. For me, it makes easier. So before you start any declination, rotate the dial until the orienting arrow is pointing directly at the index mark, and that's how it works. Just one quick point about this. Because you've now semi-permanently adjusted the direction that the orienting arrow points to, you know, when you're adjusting it, that's what you're doing. Don't forget that when you're using a compass on a map to get a bearing, use the orienting lines, not the orienting arrow, because you've just adjusted that. It's now no longer pointing in the right direction. It will be once you start using it, but when you're using it on a map, don't be tempted to use the large black arrow in the middle. Use the orienting lines. If you have one of these, or you're thinking of getting one, at least now you know how to use one. Now you know how to use one. That sounds flippant, doesn't it? It sounds just as an off-the-cuff remark. But today is the beginning of November 2025. You may have to use the way back when machine if you watch this in a few years, I don't know. At the moment today, and I googled it when I had some signal further down the valley, there is not one single set of instructions anywhere on the internet explaining how to use this compass. There are millions that tell you how to use a Kamenga or a Sunto or a Silver or a Brunton. There is not one single website, including the manufacturers. There is not one website anywhere on the internet. There's not one video anywhere on YouTube. And there's not even a downloadable PDF from anywhere to explain how to use this compass. Until now. Anyway, so hopefully you now know how to use the Breithaupt Conat 4 compass and navigate around the hills with it. Thanks for watching.